Okay, so let me start the last session, invited talk today. And first of all, I'd like to say a word about Kishida-san. And well, it's like 10 years ago, I visited Amsterdam, ILLC. And that was maybe, I guess that was the first time when I met him. And Kohei has originally specialized in logic and philosophy. And but every time I met him, well, he, kind of belonged to another cutting-edge institute of the some research group, and wrote a paper in that area that that group is specialized in. For example, he joined the research group of category theory at CMU and wrote a paper on category theory. And another time he joined the categorical quantum theory group and at Oxford and wrote a paper on quantum theory. So I've been always surprised by his versatility and his free attitude that is not bound by the boundary of the research field. So it's a pleasure to welcome Kohei at Lenus, and today's talk is titled as Modal Reasoning and Theorizing in Quantified Modal Logic. So please start.
Yeah, thank you so much for a very kind introduction. So my talk today is more about well, philosophy, or in the intersection of philosophy and logic and linguistics, maybe. So, and also, yeah, I kind of want to thank you for inviting me to this, but that's actually the next slide. So let me give you kind of an example, motivating example or scenario as an introduction. So imagine there are two crystals, alpha and beta, in front of an agent or cognizer A. There's a kind of echoing or something. Anyway, A knows that one of them is crystal gamma, a crystal that she used to own and cherish, but one day that was stolen, and she wants to really find out which of alpha and beta is gamma. So is there any clue? Yes, A also knows that gamma is not soluble in water, but that the other of alpha and beta is soluble, where soluble means there would be no more if put in water. Okay, so what should she do? Well, she decides to put both crystals in water, and whatever is left there in the water is gamma. So yeah, that'll be a happy story. Okay, so what kind of reasoning did she do? That's this. One, either alpha equals gamma and not beta, or alpha is not gamma and gamma equals beta. That's premise number one. Premise number two, gamma is not soluble. And then the conclusion. Therefore, alpha equals gamma if beta is soluble, but beta equals gamma if alpha is soluble. Right? That's that. Well, that looks like a good reasoning. So this talk will roughly put, this talk will show that the most philosophers or philosophical logicians cannot model this type of reasoning. And two, well, actually linguists can model that, but let me put it as a kind of puzzling way as a hook to my talk. Yeah, linguists can model it, but by making it invalid. Okay, so the kind of a conclusion or punchline would be this. This reasoning is a good reasoning, but only good due to some metaphysics that philosophers may get right. And actually the agent A also may get right. Okay, so so I hope that this will show that one, linguists' money was well spent by inviting a philosopher. Two, more seriously, I hope that this points to a case or a context or a topic on which philosophers and linguists should be collaborating. So this is a rough, kind of rough summary, but let me, yeah, you will see a more accurate story. But let me sort of start with this first point that look, philosophers' extensional logic cannot model inferences like the one we saw. Okay, so when we talk about when philosophers talk about actually when I mean including linguists, when we talk about say modal properties like soluble, the water, if the crystal is put in the water, it will be no more. I mean, even though in actuality the water is not in the water, it's still there. Okay, so to model that kind of situation, philosophers and other people use a possible world semantics. So A does not know whether the crystal alpha is soluble or not, will be expressed by at least two situations. The actuality in which there's a crystal in front of you, and the other possibility or possibilities in which the crystal is put in the water. But because the agent doesn't know whether the crystal is soluble or not, actually there are 4 possibilities here. So there are 4 possible combinations of truth values for the crystal is in water and the crystal is no more or has dissolved. Okay, so there are 4 possible combinations, and you're going to assign those 4 cases. And you see the 4 cases to the left. So the soluble crystal is in front of you, and that's possibility number. I mean the top left possibility, and the top right possibility is that that's put in water, so it goes away. And also bottom left possibility in which you have a non-soluble crystal in front of you. And then the bottom right possibility in which it's put in water, but it's not soluble, so it's still there. Okay. And for these 4 possibilities, you can assign truth values to these atomic sentences. The crystal is in water, crystal dissolved, and as you can see. So you are going to use 4 possible worlds. So those are 4 possible worlds, and the agent's ignorance as to whether the crystal is soluble or not is expressed by this showing that the agent cannot distinguish these 2 possibilities from each other. Okay, this is the kind of a standard way in which this is modeled. So one way to formally cache this out will be to introduce a possible world model in which there are 4 possible worlds, 4, 1, 4 prime, 2, and then you're going to say that look, in this top partition, it is always the case that in water, if and only it is dissolved. Okay, this means the crystal is soluble, and the bottom crystal never dissolves. So the bottom half means that the crystal is not soluble. Okay, and the point is again, this circle says that in those 2 situations, in those 2 possible worlds, the agent cannot distinguish whether she is in the top world, top left, or top bottom. Is that okay? There's if you are interested in dynamic epistemic logic, if you do dynamic epistemic logic, then you may say that, hey, this is a little bit too static and so on, and you need to consider model update. But sure, then the left row will be one model, and left column will be one model, right column will be an updated model, and so on. You can do that. But the point is kind of similar in the sense that even if you do this dynamic like product update in dynamic epistemic logic, you always are in one connected. If you take the sum or the union of all these possible worlds through different updated models, you will see a connected components starting from the top left or bottom left. So you can kind of translate what I'm going to say into dynamic epistemic logic. So don't kind of stop listening because I'm not talking about dynamic epistemic logic. Okay. Anyways, so yeah, okay. So the point is that the in top left, bottom left, right, okay. On bottom left, the agent knows that the crystal is there. It's not dissolved, but the agent does not know it is not soluble, even though it is not soluble. Okay, so this is how the model works. And this is the kind of the extent of the possible world semantics for the propositional part that you need to know in this block. Okay, so this is the summary of that. Now there are two crystals, okay? So A knows that one of alpha and beta is soluble, while the other is not. And the problem is that she doesn't know which one is soluble, okay? So the situation is either the left one or the right one. You may think that this is a simple enough representation, but there's a kind of a little bit of a trick here. The problem is that you really need to take these arrows seriously, because if you flip the arrows on like that, then there's no difference between the left situation and the right situation. Okay. So to say that these two situations are really, okay, I'm scared to really different situations, then you really need to take these arrows seriously. In other words, these either the so-called trans-world identity or cross-world identification of difference. That is actually at the core of the description here. Okay, you really need to take this cross-world reference seriously, or else you can't make sense of the distinction between the two situations. And that's something that is, for instance, dynamic epistemic logician, sort of, put under the rug and so on. But if you really take this soluble as a modal property, then you really need a modal property of an object, then this is something you need to do. So the upshot, trans-world identity or cross-world reference is as an essential tool you need here. So to express the premise number 2, as I kind of mentioned on the first slide, well, you need trans-world identity. On the other hand, premise 1 was something like this. A knows that one of alpha and beta is gamma, but she doesn't know which one is gamma. Okay, so there are two situations again. This is one situation, and the other is the right is where alpha equals gamma. And then the idea, well, the point is that the left situation for premise 2 and the left situation for premise 1 are supposed to be the same situation, and the right situations are the same situation. Is that okay? I hope this is visible. Okay, so but one thing we just mentioned is that for premise 2, trans-world identity of objects are really essential thing. Without having, without settling the trans-world identity, you can't talk about premise number 2. But once you start talking about trans-world identity of objects in premise number 1, yeah, we are kind of stuck with the question or difficulty of what we should be doing. One thing you can do might be this. Well, alpha is alpha, gamma is gamma, beta is beta. But then, as you can kind of see that all the six balls on the screen, which is connected. Okay, that's pretty stupid, you may say. But actually, this is pretty much what happens in encrypted semantics. Okay, I mean, encrypted semantics for quantified model logic. So let me briefly review what's going on in encrypted semantics. So what encrypted does, and many of the the usual philosophical logicians using working on quantified model logic is to take the set of world and set of individuals, and then take the kind of a product of them, or the plane consisting of those two coordinates. You're taking a like individual world pairs, like A in world W1, and so on. Okay, and then you are going to consider sort of use properties as subset of this plane. Okay, for instance, beta is red in B is red in W2 and W1, but not in W3, and so on. And then you can kind of see that for instance, this statement, hey, there's something that is necessarily red. It's true in W1, W2, W3 because, well, look at this. A is always red. Therefore, in W1, W2, W3, there's something, namely A, that isn't necessarily red. Ta-da! Okay, so that's how the semantics works. And the one upshot here is that the individual variables, like X in this case, are called rigid designator in the sense that they, well, rigidly designate, well, they basically refer to A rather than A at the W1 and B at W2 and so on. It refers, X refers to A in this case. Okay. And in a similar token, individual constants or proper names, well, according to Kripke, they are rigid designators as well. So they refer to A or B or C. On the other hand, definite descriptions are not rigid. For instance, the number of planets. So that you kind of see numbers in 7 and 8 and 9 themselves sitting in as individuals in this model, and then the number of planets. Well, that's a definite description, and it can refer to different numbers in different worlds. Okay, that's good. The red dots are the references of these definite descriptions. Okay, so there's a big difference between how proper names behave and how definite descriptions behave. Now, one thing that is relevant to this crystal example is something like this. So in this setup, semantic setup, the following principle hold, namely, as long as Hesperus equal phosphorus, those stars, those are proper names for the same star. Okay, it follows that that identity is necessarily true. Why? Well, look at the model. I mean, Hesperus, that's a rigid designator. It may refer to, for instance, the top dot in the coordinate D or the bottom dot. Phosphorus, similarly, refers to either a top dot or bottom dot. If they agree, then they are always the same throughout all the possible worlds. Okay. So the as you can immediately see, this semantics cannot, therefore cannot model situation like A does not know whether alpha equals gamma or not. As long as you take alpha and gamma as the names, proper names, and the names for the crystals. Because, well, I mean, sure, I mean, that Kripke model, the semantics could say that, hey, the agent A does not know whether the crystal alpha is soluble or not, because there are two possible, well, two partitions, the red partition and the green partition. And the circle crossing over the partitions properly expressed, neatly expressed the ignorance, A's ignorance about solubility of alpha. But when it comes to the identity of alpha with the gamma, you want this, but the setup, semantic setup, doesn't allow that. It's either this or that. Whereas you need those two partitions. I mean, if alpha and gamma refers to the same thing on that d-axis, then yeah, they always refer to the same thing. Or if they refer to the different thing, to two different things, then they, I mean, refer to the same pair of things throughout all the worlds. There are no two partitions. There can be no two partitions like this, which you need to express A's ignorance of the identity of alpha. Okay, so let me expand a little bit. So Kripke had this famous thesis that some necessary facts can still be a posteriori facts. So Hesperus equals phosphorus is necessarily true for the reason we just described. But on the other hand, Kripke is well aware that that's an a posteriori fact. That's something we discovered empirically, right? We in the sense of the human race, Western tradition, I guess, introduced those two names to two stars, thinking that there may be two stars, but it turned out that those two stars were identical. So they just empirically found out that Hesperus equals phosphorus. And therefore, that's a posteriori fact. But it was a necessary, necessary truth for some reason. Okay, let's say for some reason. And similarly, alpha equals gamma is an a posteriori fact. I mean, this agent A doesn't know whether alpha equals gamma or not. But the point is that by putting alpha and beta, there's two crystals in water, he will learn that, assuming that alpha equals gamma, she's going to find that out. Now, so Kripke's semantics, the actual Kripke's models, Kripke's semantics can model the necessity of identity. Sure. But the problem is that it cannot model the a posteriority of identity because it cannot express. It cannot represent an agent to be ignorant of this equality. Because the identity is the case throughout all the possible worlds. Okay? And actually, the situation is even worse. It's not just about the identity. Yeah, yeah. So consider. Remember, we have this assumption about the situation. A knows that alpha is not the gamma, but gamma is rather beta if alpha is soluble. Right? So if the semantics cannot model this a posteriority of what A does not know about alpha equals gamma because it has alpha equal gamma in every world, then neither can it model the following, namely, A does not know that alpha is soluble. this ignorance cannot be modeled either. Let's go back to semantics, right? I mean, the thing is that the alpha's non-identity with gamma or alpha's identity with gamma are correlated with the solubility or non-solubility of gamma, oh sorry, alpha. But because of that, this rigid designator business, either the model can be this or this. So there's no way to have this either. As long as you are going to assume that the solubility and identity are correlated. Okay. So the question I'm going to discuss is how can the necessary a posteriori in general be a posteriori? I mean, is there any semantics or logic in which we can represent necessary a posteriori as a posteriori? Okay. Let me quickly. So just in case you are like a little bit more familiar with quantified model logic and its semantics, and you may think that, okay, there are the counterpart theories. Then it looks like this. I mean, yeah, sure, you're right that they are in that case you can at least express the non-necessity of identity in such a way that, hey, this is an example of due to Gibbard. So in reality, you may have this statue called Goliath and this lump of clay called Lampo. And they are actually the same thing in this actual world. But Goliath, the statue, could have been made with, for instance, bronze. And the lump of clay may, well, for instance, but on the other hand, yeah, I mean, Goliath, the statue may be crushed into just a lump of clay. Then the lump of clay will still be there, whereas Goliath, the statue, will be gone. So the identity between the Goliath, the statue, and the lump of clay are not necessary. It's not, I mean, they are not necessarily identical. That's Gibbard's example. I mean, the point is that there are these features or properties called sortals, and they are supposed to give criteria of identity. For instance, statue is going to give an identity to Goliath, the statue. Okay, so the Goliath statue, the statue that is actually made of lump of clay is identical with this possible Goliath, the statue made of bronze. The lump of clay, which happens to have the form of a statue in this actual world, it may be actually the same thing as the lump of clay, which is of the statue form and so on. Anyway, the statue property or feature is going to pick up one criterion of identity. Lump of clay is going to pick up another criterion of identity across different worlds. Sure, fine. Yeah, but I want to point out whether a given concept is a sortal or not can be a posteriori thing, because that may depend on, say, fundamental physics, right? I mean, what kind of particles there are in this universe and so on, and those concepts are going to determine, certainly going to determine another criterion of identity and so on. So that's something we are going to find out. So let me kind of summarize the problem here. So in the case of sortals, yeah, they give criteria of identity across different worlds. Even though whether a given concept is a sortal or not can be a posteriori. Yeah. So in this counterpart theory, sortals are going to give so the it's a part of the semantics that cash out what is necessary and what is not, even though that's an a posteriori fact. I mean, those are a posteriori things. And actually, a similar thing we can kind of see about with critique as well. So there was this identity as necessary principle, and why it is so was explained by the semantics once you have the semantics. But actually, I mean, that's not the reason Kripke gives in his famous book. That's I mean, hey, look at this semantics, and then the identity necessary was not the celebrated argument by Kripke. There was this causal theory of the reference by the proper names and the naming, and this sort of chain of events and so on. I mean, yeah, Kripke spent pages describing that, as opposed to this simple semantic, simple formal explanation. In other words, so my point is here. Philosophers arrive at these metaphysical principles like what are solvents and so on, or this principle that identity is necessary and so on, by certain reasoning, which may involve some a posteriori facts, for instance, in the case of solvents, but their semantics, on the other hand, so they have this philosophy, lengthy philosophical reasoning to justify those, but their semantics simply reflect the end results of those reasonings as part of the definition or mathematical makeup of the semantics. So a simple observation is, so we do not really have the logic that philosophers use in this reasoning, right? Philosophers can use the really substantive argument to come up with these metaphysical principles. But look, in their logic, in their semantics, they are just matters of logic. Well, it just follows from the mathematical makeup. The end of it. So we really. So at least when it comes to representation of agents, reasoning, and so on, how can agents come to know such principles? It's totally left unexplained. Okay, so let me summarize part one, because it was kind of a lengthy, convoluted discussion. So this is the summary. Philosophers' extensional modal logics each have their own metaphysical principles built in to the mathematical makeup of the semantics as matters of logic rather than substantive facts. Therefore, the logics and the semantics cannot model how agents come to know these principles, as well as necessary a posteriori facts whose necessity arises out of those metaphysical principles, which is not necessarily bad. But if I want to give a representation of those reasonings, then yeah, sure, it simply doesn't work. Okay, so that's part one. And part two, ta-da, here's another approach, intentional quantified modal logic by Montague and others. I'm going to use the formulation by Aldo Bressan and other, other sort of my supervisors, my teachers, and so on from the University of Pittsburgh. But anyway, mainly because they certainly have certain philosophical point I want to sort of not iterate, but I'm expanding on their Bressan's point. So let me go with this formulation by Bressan. In that formulation, we are going to take kind of a bunch of sets above each world. And for each world, we are going to assign, well, let's say different. Categorically, it's the same thing. It's equivalent. The category theorists would say, don't worry about it. But anyway, let's take disjoint sets of individuals living in world 1, world 2, world 3, and so on. And then this central concept of the semantics is individual intention, which is either a function alpha from the set of worlds W such that for each W input W, its output alpha W lies in the set DW union with some like designated element dot star, or equivalently a partial function alpha from W such that alpha of W belongs to DW as long as it is defined. Category theorists say that, hey, those two are equivalent representations of a partial functions. So in the remainder of the talk, I'm going to use this star a lot, but do not take this too heavily. I do not mean to make a significant metaphysical assumption. If you don't like it, replace everything with a partial function. Okay. Anyways, what is the meaning of this? This is an individual intention is going to assign to each world W a alpha of W that is alpha's extension of world W. Okay, so that's the role of individual intention. Individual intention is a function or partial function that is going to pick up the extension of that expression alpha or intention alpha from each world. And then I'm going to write pi for the set of all individual intentions. Because it's kind of pi, but anyway, don't worry, don't worry. Anyway, okay, so it's good. And then here, because on this picture, beta doesn't have any like beta doesn't extend over W5 because beta of W5 is either undefined or equals the star. Okay, beta doesn't have an extension in W5. Okay, now. So this is one picture, and then interesting thing is that in this intensional logic, the variables, individual constants, and definite descriptions, they all behave the same, uniformly the same. So variables are explained over this this set pi of individual intentions. Constant C, yeah, each constant C refers to some individual intention. And function symbols also works in such a way that it's a function from, if it is an n-ary function symbol, then its interpretation is it's an n-ary function from the individual intentions to the end to another individual intention. Okay. So for instance, in this picture, red intention doesn't have an extension in W5, but still the function. So let's take two individual intentions, Aristotle and Kennedy. Okay, they are no more in this actual world. So if I say something like Kennedy is the youngest offspring and Aristotle the youngest offspring, do they need to refer to the same thing because they are both no more? No, because a function is interpreted by a function on individual intentions. So even if Kennedy and Aristotle refer to the same thing, star, in this actual world, in this actual moment, they may have different extension when it comes to Kennedy's youngest offspring and Aristotle's youngest offspring. Okay. Now, so this is one picture. Based on kind of, extensions in each world. But actually, you can also rewrite those in terms of all the individual intentions. We draw the picture using all the individual intentions that may like intersect sometimes. I think, yeah, you can kind of see the picture. Here's one picture, stretch it back, stretch it back. I hope I don't need to spend saying anything worse. I hope you can. I hope you can sort of see the equivalence between them without proving it. But yeah, they are equivalent. So, for instance, this is one situation, and that means that they do not have an extension, or in other words, they have the extension star in those worlds. Okay. Based on this, I have like 11 more minutes, right?
Yeah, you can use your time flexibly.
Okay, then yeah, okay. I think I'm gonna work. Right. So now again, based on this, we can talk about predication. And now, in general, predication again is intentional. So if f is a n place predicate, then its interpretation is going to assign each n tuple of individual intentions sort of a proposition in the sense of a subset of the set of worlds. So, for instance, you can. So I hope the picture again explains it. So here, this is the intention-based picture, and then the property or the predicate green is interpreted in this way. So, for instance, beta. Look at the this intention beta. Beta is green in W2. W3, W4, W5, because that's where those are colored in green, whereas it is not green in W1. Okay. Alpha is always red. And also alpha equals beta is the case in W3, as you can kind of see from the picture. X exists is interpreted by X not being, or X not being this weird non-existent individual star. Now, predication is generally intentional in the sense that look at the alpha and the beta in W3. They are the same. They have the same extension, but that extension as an alpha is green, is red. That extension as beta is green. So even if they have the same extension, they may still have different truth values when it comes to whether it is green or not. Hence, intentional. Of course, it can be extensional, but generally, predication is intentional. Quantifiers, well, you can sort of. That's kind of obvious. Some X that exists is blah, 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 will be an interpretation of the quantifiers. Modalities, you can also define it as in every world, or you can also write something like X exists only if it is blah, blah, blah. Or, I mean, you may interpret box in different ways. It's always the case whether it exists or not, or you may restrict the range of in all possible worlds as worlds in which that X actually exists. That's up to you. And actually, you can do it both ways. That's a virtue of this setting. Anyways, let me get back to this bit about individual terms. So variables, constants, descriptions do not matter. They all refer to individual intention. So, for instance, the case of the number of planets will could look like this. And also alpha and the beta and gamma can also look like this. And ta-da, you can now express alpha in one situation, in one possible world W3, alpha equals gamma, and gamma equals alpha but not beta, and on the other world, gamma equals beta and not alpha. Ta-da, you can express that. So much good. Let me get to the part 3, where I'm going to talk about the expressive power of the intentional logic. I need to talk about this for at least for 2 reasons. One is this. The top picture has can cause you some concern. Namely this, when philosophers talked about the number of planets, they wanted to distinguish 2 things, 2 sort of reading of the following sentence, namely, the number of planets is necessarily greater than 7. And there are 2 readings. In one, it is false because the number of planets, there could be only 7 planets. It's possible for there to be only 7 planets. Okay, in that so that's one reading in which that sentence is false. But there's also another reading in which this number of planets is actually going to pick up the number 8. And then that number 8 is necessarily bigger than 7. That's a kind of a triumphant story by philosophers. But one concern that can be raised against this is that, how can the second reading be like possible there? Because everything, like the number of planets and 8, those are both individual intentions. So why are you going to talk about 8 in particular in this reading? The number of planets is necessarily greater than 7. There's no mention of 8 in that. And the philosophers could pick up 8 because that is the rigid designators. That is the rigid designator. That had a privilege. There was a distinction between definite description, the number of planets, and the definite description 8 that refers to that number itself. So that number itself was something that was used in this in guaranteeing that, hey, there is a true reading of this sentence. The number of planets is necessarily greater than 7. But in this everything is intention setting. There seems to be no place for that reading. Okay, so that's the concern. That's the concern, and that's one of the reasons why I have to talk about this expressive power of the intentional. Okay, I think I'm gonna, anyway. So here's the one situation. Here's one thing for instance, the intentional logic can do. For instance, Goliath is a statue, not clay. So let's say green is clay as a state, sort of. The Goliath is kind of by essence not clay. Okay, so gamma on the top line, top intention is Goliath, and in W3 that has the same extension as something that is essentially clay, namely the lump of clay, but Goliath is not clay in that sense. On the other hand, you can also say something like Goliath is made of clay, essentially. Okay, so one way to, so how can we express that? Well, use this logical formula. There's some intention that is essentially clay, and that exists and that happens to have the same extension as Goliath, namely the lump of clay. Okay. So general upshot is that hey, there are properties of properties, like made of clay. Sorry. So this property, blah blah blah, is made of clay, has certain like property, like existence implying or extensional and so on. So putting detail aside, this kind of metaphysical properties of properties can be defined using the logic. That is the expressive power of this intentional logic, and that is going to be used. This expressive power is used to, define the following property number 3, which may be the most important property of today. So first, let's introduce this property, namely phi. This property phi of individual intention is modally constant in the sense that they are, when something satisfies that, then it always satisfies that. When some intention doesn't satisfy it, then it never satisfies that. Okay, like in this picture. Every intention is either totally green or totally red. Second component, X and Y are parallel. Defined this way, but it's more like alpha and beta in this picture are not parallel because it sometimes intersect with each other. They sometimes do not. I mean, except when they are both non-existent. When they are both non-existent, then yeah, they collapse as a star. But as long as they exist, they are either always the same objects. I mean, they always have the same extension. Okay, those are parallel. I mean, this is a parallel between two individual intentions. Now, here's the most important bit. This property of an individual phi is, we call it absolute, if and only if phi is modally constant and moreover modally separated in the sense that they are, whenever two individual intentions satisfy that property, then they must be parallel. In a picture, it looks like this. If, hey, this is one individual intention satisfying that absolute property, this is another. I mean, as long as they differ somewhere, they never intersect. Another, they never intersect. They never intersect. They never intersect. Okay? So, cleaning up the picture, it will look like this. They are a bunch of parallel lines. Okay? So, for instance, let's introduce this let's define that, hey, there's this property is a number, and let's assume, let's make kind of an axiom that is a number is an absolute property. Then you can kind of say that 6, 7, 8, 9 are individual intentions that are number in this absolute sense. Whereas you can make a distinction between those absolute numbers, numbers in the absolute sense, and the number of planets. So the number of planets is always has the same extension with numbers in the absolute sense, but that intention itself is not a number in the absolute sense. And then using that, you can kind of express the two different readings. Don't have time, so I'm not going to get into detail, but okay. So 2 more slides, maybe 3 more. So, okay, we have just seen that the intentional logic has a strong expressive power, and actually it enables us to redraw, in a way, a logic theory distinction in modal metaphysics, and for instance, in the following way. For instance, we can use intentional logic to axiomatize cryptid semantics as a theory in that logic. So the idea is kind of well known. You can introduce a predicate, for instance, is a thing has an absolute property and satisfying the following property, that for every intention, it always has the same extension as a thing or thing intension. So it looks like this. And then you can also introduce that for all proper names. They refer to an individual intention that is a thing in this absolute sense. So it looks like, yeah, the picture looks like this. And you can kind of see that, hey, this is kind of equivalent to having a plane, right? Because there are a bunch of parallel lines, and you can kind of consider this as giving one coordinate. And then you can translate Kripke's languages into ours. Like he's a universal quantifier means for everything. And then x is necessarily phi is interpreted as whenever you take a thing intention that has the same extension, then that thing satisfied phi necessarily, and so on. And then for each predicate, I skip this part. The point is that this theory then proves, for instance, the translation of this principle in Kripke's logic, namely every identity is necessary. Okay. Now using this, so this is a logic theory distinction, and let me sort of. So this is let's go back to the crystal. So firstly, the intentional logic can deem the ignorance of alpha equals gamma consistent with its necessity in this picture. Here, as we saw that here's look, gamma may be alpha or beta. But if you sort of divide them in partition, then you can still say that they are necessary. So in the left partition, red and green are always the same. Always have the same intention. In the right partition, blue and green always have the same partition, have the same extension. So it's good. Okay. Now, this is the most important thing I wanted to say. I hope I have time. Yeah, but the semantics shows that the agent's reasoning 1, 2, 3 that we saw on the first slide is invalid. Here is a how. So look, this is again the same situation, but now gamma is not soluble, means this. Gamma is never soluble, right? Never goes to star. And then, therefore, so if beta is soluble, then alpha equals gamma. It doesn't follow because there is a counterexample. Yeah, because even if here alpha, say W1, red and green have the same extension, and they are, and green is not soluble, but green, like Lampol and Goliath, they are going to refer to different things in W3. So red is going to be dissolved in water in W3. Here's a counterexample. That's strange. Can we say? But the point is this. Yeah, but there's an easy way to solve this reasoning. Namely, let's assume that the agent knows that. See, there's absolute concept of is a crystal, and alpha and the beta and the gamma are just crystal in the absolute sense. Those are intentions that are absolute crystal. Then yeah, that forces us to that forces the model to be like this. Therefore, the premise is 0, 1, 2 entails 3 in this logic. So yeah, the logic semantics demonstrates the role of such metaphysical assumptions. It doesn't have to be like 0. There may be other metaphysical assumptions you can make to let the 1, 2, 3 go. But the point is that there must be some metaphysical principles, like 0, in the agent's correct reasoning 1, 2, 3. And that's something that that's something linguists and philosophers must collaborate on. Sure, linguists have this, expressive power, but how, I mean, where to get that kind of metaphysics? Well, that's philosopher's job as well. Okay, so that's the end of my. So here's a summary of my talk today. Nothing to add. So thank you so much.
Well, officially it's 1 minute and a half, but let's have some discussion time here. Sure. Many comments and questions, but I think it's probably interest of time better to, stick to one of them. It's kind of interesting conclusion, but I kind of want to have a different conclusion from your final one about collaboration philosophers and linguists. And I think that the key point that you made in your consideration, that's yes, why the reasoning is unsound, because, for example, the agent can see that when the crystal is put in the water, that it's like shell games, right? If somebody puts the crystal in the water, you don't know that it's put crystal number 1 in water. Maybe the switch crystal, once you're not looking, right? And if I myself put the crystal in the water, then I know that if I take it and put it in water, because that I had in my hands, that's the one in the water, right? So it's like a shell games, right? So if you try to play somebody else put the crystal in the water, you can never trust them if they switched or not. Yeah, so that's essentially, and the assumption, what it's not stated is that we assume that she herself put in the water, that therefore she knows that nobody switched.
That's some kind of thing that you can do even before my talk. Yes. So so counter example will be something like, yeah, but actually gamma is a definite description, like the most beautiful crystal in the world. Yeah. Right. As soon as it's put in the water, it's no more. So beta is going to be the next most beautiful crystal in the world. Yeah. And then that's sort of the counter. Yeah. So the point is that, but. So
the zero is actually, is absolute. This means that, it's, well, one of the world, it's, the crystal, outside the water, another world is in the water, right? And that the assumption is that, when you put in the water, then, it's the one that it was your hand was put in the water, right? And if you say put in the water, so you ask somebody else to put in the water, that somebody else might actually switch them around, and then you don't know which one is actually, was in the water or not, right? So, but that is kind of, yes, it's but you can say this is like, in AI standard thinking, so there is a lot of common sense reasoning that, when the phrase says put in the water, then there is a background assumption that I put in the water and that it remains was in my hand. So, and then you explicate that, yes, our reasoning requires a lot of background knowledge and assumption that is usually not stated in the reason. And then, yeah, if you kind of consider it strictly, then we have to take this into account. Well, I agree with it in your sense, but it's
so okay, that's sure. So for instance, if we do forensic science, then you need forensic scientists' help, not just the logicians' help.
Yeah, so
right? So I'm kind of adding a metaphysics, not just linguists' help, right? Linguists is not qualified to settle. You need help from forensic scientists. I'm just saying that, hey, also you need a philosopher as well.
Okay, so if I summarize, so what you, well, to me, how I understand your talk is that, yes, in a lot of puzzles like that, there is a lot of background reasoning, which, kind of common sense knowledge about, that if we put things, on the one hand to move it around, that it was the same thing that we moved before, and that it's so obvious that we don't, bother to state it, but it actually has to be stated because otherwise, strictly speaking, reasoning doesn't hold through.
It's okay. I mean, for instance, in the case of forensic scientists, you don't need this this much material, this much gadget. My point is that you need intentional logic as opposed to extensional logic. If you need to specify that local philosophers help, that assumption is doing another essential role here.
Okay, so I take the point. So that means that, I mean, saying intentional logic, it means there is maybe some process that make you doing moving, which may, I mean, switch things, I mean, behind your scenes, right? So, which is the something that we don't know. I mean, how
that's more
right?
like I don't know. I mean, the referee or the scientist and so on. Yeah, sure, that's fine. Because I mean, the soluble and other kind of things. Of course, I'm not saying that the logicians and linguists can solve all these world problems. Yeah, I mean that's totally fine. I just say that hey, if you give I mean forensic scientists a job, please give philosopher a job as well. Is that like a I don't know. I mean, is that like a well, I don't know. As long as I can get a job, I'll be you know satisfied. But yeah, I get the point. Yeah, sure. I mean, in many cases, logic alone doesn't solve everything, right? That I mean, all logicians know that. I mean, there are premises. And I mean, from the beginning, Aristotle said that no, logic can't solve everything.
Okay. Yamada Sensei, could you please ask the question?
Thank you for the talk. It was very interesting, but I have one worry about that, what you have said. That concerns your remark about Kennedy or Aristotle.
Mm-hmm.
They died long ago.
Mm-hmm.
So you say they do not exist in this world.
They are no more in the sense that they have joined the star.
So for example, we can make true statement about Kennedy, say.
Yes, that's the whole point.
He died many years ago, so it must be possible to refer to Kennedy.
Yes, but we refer to Kennedy because we are going to refer to the individual intention Kennedy. Whether that has an extension in this moment or not, it doesn't matter because it's an individual reference and intentional reference.
You say that the intention has died.
No. Intention has died in the sense that it has no longer have an extension.
Wait. So just the statement that Kennedy died many years ago.
Mm-hmm.
If it is true,
yes,
then the referent of Kennedy died many years ago.
Yes.
If the referent of Kennedy is intention, then you say intention died many years ago.
No, that's not.
So the referent cannot be the intention.
Yeah, but I mean, yeah, but even if for instance, even in the case of crystal, when crystal dissolves, there still are red intention going through all the possible worlds. It's just that the red happens to refer to the star in that world where this crystal alpha is no more. But I'm using this as scarecrow to know more.
Yeah,
because
I think the existence may be ambiguous.
I kind of see that similar point.
My worry just concerns if we say that Kennedy died many years ago and it is true, then the referent of the Kennedy, our use of Kennedy now, still something that can be referred to and
Yes.
of which it is true that it died many years
Yes,
ago.
yes. I mean, in the sense that that intention used to have an extension up until some years ago. It doesn't anymore. That's what the died
So,
is supposed to mean in this setting.
so what died is referent but I think, in order for the statement to be true.
I mean, yeah, but intention never dies. I mean, in a sense.
Right. So that is
Yeah,
that's my
intention never
worry.
dies, but that's the only possible meaning of die in this setting. Because intention goes through all the possible worlds. So
Right.
yeah, it can be.
So that my worry about treating intention as a referent.
I don't know. I mean, I'm a little bit. I'm finding it a bit. I don't know. Difficulty of finding the kind of the extensional. I mean, intentional reading of dying as opposed to extensional reading of dying. So yeah, dying is a little bit, but the point is that yeah, there are intentional predication and extensional predication, and the logic is strong enough to distinguish two cases, like being essentially clay and being made of clay extensionally. Those are two things you can distinguish, for instance, in the setting. So I'm kind of I don't know at the loss how else I can put it. I mean, formally you can. I shouldn't say that because I'm also a philosopher, so I have to explain it in conceptual terms. But let's see. I mean, so the point is that yeah, you can kind of die as meaning, losing extension. You can
You can also use other predicate. For example, we may say Kennedy liked women.
Yes.
It is true.
Yes.
And,
Yes.
it must be possible for us to refer to Kennedy.
Yeah. But the reference is intentional. That's why I was talking about Aristotle and Kennedy having two different youngest offsprings, even though they like both joined the star a long time ago.
Yeah. But so is the intention of Kennedy likes women?
Yes.
Really?
I mean, extension. If you read likes women as an extensional predicate, then yes, Kennedy is now the star, so it cannot really like women here. If you're talking about like some essential property of, I don't know, super womanizer or something that goes through all the, I mean, then yeah, I mean, Kennedy is still essentially a super womanizer. That's totally fine with this logic. Logic can, the point is that logic can distinguish those two notions.
Just a contingent
Okay,
fact about Kennedy.
we have to leave it here, so you have to stop here.
Yeah.
And
Okay,
let's
I
continue.
stop. Yeah, thank you.
Somewhere else. Thank you very much for the question. Okay, maybe we'll spend out our time. So maybe, let's thank the speaker again.